Good morning and welcome to Thursday's maths lesson. Today we're carrying on with the scaling activity. So we started this at the beginning of the week, looking at sizes of different animals. Yesterday we reminded ourselves of how to half and how to double, whether we're scaling up or whether we are scaling down. So the aim of today's lesson is I can solve problems by scaling up and down, and your success criteria today that you can use known multiplication facts to scale up, like you did yesterday, you used your 2 times table because we were doubling, that you can use known division facts to scale down, like you did yesterday, you divided by 2 when you were halving, and that you can find the scale factor from 2 given measurements. That means the relationship between 2 measurements. Let's have a look at this together. If you get yourself a pen and a piece of paper, what I would like you to do to start with is to find 2 numbers whose sum is 10. That means whose numbers added together equals 10. And also their product is 16. That means when they're multiplied together, they equal 16. You might want to use trial and error and think about your number bonds to 10 to work this out. If you pause the video now and have a go at working this out. Let's have a look at this one together. So the 2 numbers that add together to make 10 are 8 and 2. And we know that 8 times 2 is 16. 8 doubled is 16. We also know with an addition number sentence, it's commutative. You can swap it around. So 2 add 8 also equals 10. And 2 times 8 also equals 16. So they are the 2 numbers. Let's have a look at another example. So here's a challenge. Can you find 2 numbers whose sum is 8? So when they add together, they equal 8. And their product is 12. When they're multiplied together, they equal 12. Pause the video now and have a go. The 2 numbers you were looking for are the numbers 6 and 2. We also know that 2 add 6 also equals 8 because they're commutative. You can swap them around. And also we know that 2 times 6 equals 12 and also 6 times 2 equals 12. So there's a reminder about relationships between numbers and also some of our multiplication tables. In today's lesson, we're going to be thinking about scaling models. I've got a picture here of some different scaled models. We've got a car, a train, a building, and an aeroplane. You guys may have been to a model village before or have model planes, and they are all made to scale. So let's think a little bit more about what that means. So scale models. Maps, models, and drawings are all things that can be made to scale. Something that is made to scale has the same proportions as the real thing, but is larger or smaller. So it means it looks exactly the same, but is small or big. And we'll look at some examples of both in a moment. Scale models have a scale factor, which tells you how the size of the model relates to the size of the original thing. This scale model of a toy car has a scale factor of 1 to 3. Everything on the original is 3 times bigger than on the scale model. Let's investigate this a little further. 1 centimetre on the model, therefore, is the same as 3 centimetres on the real car, because 3 times 1 centimetre is 3 centimetres. 2 centimetres on the model is the same as 6 centimetres on the real car, because 3 times 2 is 6. 50 centimetres on the model is 150 centimetres on the real car, because 3 times 50 is 150. Have a look at this one. Scale factor 1 to 3, so we know that the real car is 3 times bigger than this scale model. So what is the length of the real car if the length of the model is 100 centimetres? Pause the video now and have a go. Let's have a look. So I know that the scale model is 1 to 3. So I know that I need to multiply that 100 centimetres by 3, and the answer therefore is 300 centimetres. Let's have a look at another example. What is the width of the model car if the original car is 60 centimetres? So I know that the original car is 60 centimetres, and I know that the model car is 3 times smaller than that. If we are making it smaller, we're going to be dividing it. So the width of the original car is 60 centimetres. I need to divide that 60 by 3. Let's think what I know. I know that 6 divided by 3, 6, is 2. Therefore, I know that 60 divided by 3 is 20. So the width of the original car is 20 centimetres, because I know that 60 is 3 times bigger than 20. This model aeroplane has a scale factor of 1 to 48. We know that an aeroplane is really, really big. So it's 48 times smaller than the real thing. So the real thing is 48 times bigger than the model. This doll's house chair has a scale factor 1 to 18. It is 18 times smaller than the real thing. The real thing is 18 times bigger than the model. Let's look at something the other way round, where the model is larger than real life. This is a statue by Nina Akmu, and it's called American Horse. It has a scale factor 3 to 1. It is 3 times bigger than the real thing. Today, we're going to be thinking about a scaled model of a playground. Your activity today. The children of Park Primary School have been given the task of designing a new playground for their village. They must build a scale model of their playground in order to show the builders what they want the real playground to look like. They will make their model 4 times smaller than the real playground. This means that every 1 centimetre on their model would be 4 centimetres on the full-size equipment. The model is a quarter of the size of the actual playground. It has a scale factor 1 to 4. The model slide is 60 centimetres high. So how high is the real slide? The real slide is 4 times the height of the model. To find the height of the real slide, you need to multiply the height of the model by 4. Now, last week, you looked at using multiplication, a 2-digit number by a 1-digit number, so you can use that to help. So if the model slide is 60 centimetres and you need to times it by 4, you know that 0 times 4 is 0. But you also know that 6 times 12, you also know that 6 times 4 equals, let's work it out together. So we've got 6, 12, 18, 24. You know that 6 times 4 is 24. So I know, therefore, that 60 times 4 is 240. So that is the height of the real slide. Let's have a look if the model was made to a different scale. Can you calculate the length of the real slide? So 1 to 4 scale, the real slide is 4 times bigger than the model. The length of the slide on the model is 80 centimetres. We need to multiply 80 centimetres by 4. Pause the video now and have a go. Let's have a look. You can use exactly the same method as we looked at last week. Looking at our tens, I know that 8 times 4 is 32. Therefore, I know that 80 times 4 is 320. So the length of the slide is 320 centimetres. Let's have a look at a different scale. So let's calculate the length of the real slide. It's a 1 to 8 scale now. So we're going to be thinking about multiplying by 8. The real slide is 8 times bigger than the model. The length of the slide on the model is 20 centimetres. We need to multiply 20 centimetres by 8 because that's the scale we're working to. So I would like you to work out 20 centimetres times 8. Pause the video, please, and have a go. So we've got 20 times 8. I know that 2 times 8 equals 16. So therefore I know 20 times 8 is 160. So the length is 160 centimetres. Don't forget to record the unit of measurement. What if the model was made to a different scale? Can you calculate the length of the real slide? So it's a 1 to 10 scale now. The real slide is 10 times bigger than the model, and the length of the slide on the model is 25 centimetres. So we need to multiply 25 by, it's a 1 to 10 scale, so we need to multiply it by 10. So we need to do 25 centimetres times 10. Now you know how to make 25 centimetres 10 times bigger. If we had a place value chart and we had our 100 tens and ones, you know to make 25 10 times bigger, it moves across one place. So the answer is 250 centimetres. Don't forget to record the unit of measurement. The height of this climbing frame, the real climbing frame, is 400 centimetres at its highest point. On the model, the tallest point of the climbing frame is 40 centimetres. What scale did they use and how many times bigger is the real playground? Could you pause the video now and have a little think? Because we're working on thinking about the relationship between these numbers, we need to think about the relationship between the scale. So it's 40 to 400. What do I know about the relationship between those numbers? I might think about what times tables are they in? What times table do they both appear in? Or I might know from just looking at them. So I know from just looking at these numbers that the relationship between them is that 400 is 10 times bigger than 40. So the ratio is 1 to 10. If my measurements were 20 and 40, I know the relationship between 20 and 40 is that there are 2 20s in 40. So I know the relationship there is 1 to 2. So it has been doubled. These ones are tricky, so if you find them difficult, you can always send me a message. I'm going to be uploading onto Class Dojo today 3 sheets. 1 star is like our red activity in class if you're not very confident. 2 stars is the orange activity if you're feeling a bit more confident, and 3 stars, the activity if you're super confident. You do not need to print these out, just please label them clearly so I know what one you're doing and what answers you are answering. If you have any problems, please let me know. So a reminder today, you're thinking about scaling up and scaling down. When you're scaling up, you're thinking about multiplying, making something bigger. When you're scaling down, you're thinking about dividing, making something smaller. If you have any questions along the way, please drop me a dojo and I look forward to seeing your work. Take care, everyone.